let us go through this chapter. So this is chapter 9, integration. First of all, we have the syllabus of integrations. So basically you can see something like indefinite integration at the first part, definite integration as the second part. After that we have area and volumes. Okay, so 9.1 indefinite integrations. So what we have here is integration as the reverse of differentiation. So the concept here is when we do differentiation, y after differentiation it becomes dy dx. But when you do integration, dy dx, you integrate, it becomes y. Now we look at part B. Part B, if dy dx equal to fx, then integrate fx dx equal to y plus c. So it means you integrate the derivative, then you will get the y plus c. Okay, now let us look at example on the reverse of differentiation. So we can try questions from, let's say, the past paper, page 36. Okay, I do it at the side here, page 36. Okay, let us try question 2. So the question is given us fx equal to x squared over 2x minus 5. Okay, so we have to find f prime of x, then hence evaluate this. Okay, so this is a 5 marks questions. So in order to do this, what we need to do is we have to do differentiation. We have to use quotient rule. So we let the numerator as u, the denominator as v. So f prime of x is basically v square. So v du dx minus u dv dx. Okay, so after differentiations, we simplified it. Let's say I just expand it, or I factorize x, then I expand the rest. So I still have 4x minus 10 minus 2x. So at the denominator I have 2x minus 5 squared. Okay, so x, 2x minus 10, 2x minus 5 squared. I factorize the 2 from the numerator, 2x, x minus 5, 2x minus 5 squared. So this is the f prime of x. Okay, so once we have f prime of x found, now we have to use it to evaluate the integral. Okay, so we need to integrate this x minus 5, 2x minus 5 to the power of 2. We understand that when you integrate, if you are integrating dy dx, then you will get y. Okay, so because of that, we are trying to change the integral to dy dx. We try to change this to dy dx. So how to change? You see, we have 2 in front, so we need 2 over here. Okay, so we multiply with 2 purposely over here, but of course if you multiply with 2 over there, you are changing the value of the questions, and because of that we divide by 2 outside of the integral. Okay, so now we have 1 over 2. Okay, so everything inside here is now the dy dx. It's dy dx. According to the formula, when you integrate dy dx, you will get y. So that means you will get fx for our case here. Our fx is x squared over 2x minus 5. So we will have this. And after that, we substitute the upper limit into the x, 2 squared, 2 minus 5. Then we substitute the lower limit, 1 minus 5. Okay, then we press calculator. Okay, so what we get is we have 4 over negative 1 minus with 1 over negative 3 divided by 2. Okay, so we get negative 11 over 6. So that is the final answer. Okay, now let's check to make sure this answer is correct. Okay, yes, this is correct. Okay, so that is how we handle the reverse of differentiation. Okay, we look at the next page. So on the next page, we have general integrations formulae. So the first one, integrate k, you will get kx plus c. Okay, so one example, let's say if you integrate pi, basically pi is a constant, and then you will get pi x plus c. Okay, number 2, integrate x to the power of n, then you will get x to the power of n plus 1 over n plus 1 plus c. So what happened is we plus 1 to the power and then we divide by the n plus 1, the new power. Okay, so example, if I have 1 over x to the power of 1 over 2, I want to integrate this. I need to bring up the x, so it take negative power. Then I can use the formula. I need to plus 1 to the power. Negative half plus 1 is positive half. Then divide by half. Then plus c. Simplify. 2 square root x plus c. Okay, now next one, number 3. Let us look at the formula. Integrate ax plus b to the power of n. Then we will get ax plus b to the power of n plus 1. So what happened here is we plus 1 to the power, and after that we need to divide by 2 things. The first thing is a. Okay? The second thing is n plus 1. Okay? We need to divide by 2 things. Okay, now let's see one example. If I have integration of 5 minus 3x to the power of 2. Okay, so by using the formula in number 3, I need to plus 1 to the power. 5 minus 3x plus 1 to the power, I get power 3. And I need to divide by a. The a is negative 3. Okay, so the coefficients of x basically. Then the n plus 1 is 3. The power, the new power, plus c. Then I simplify this, I will get negative 5 minus 3x to the power of 3 over 9 plus c. Okay, now we look at formula number 4. Okay, so integrate ex dx equal to ex plus c. That means integrate exponent to the power of x, you will get back exponent. Okay, so no example for this. And we move on, number 5. Integrate e to the power of ax plus b. So you get 1 over a. Where is the 1 over a coming from? It is from the differentiation of the power. Differentiate ax plus b, you get a, then you divide by a. So you divide by a, that's why there is 1 over a over there. And after that, e to the power of ax plus b is the same exponent plus c. Okay, so let's say one example, number 5. Okay, so let's say I have let's say 1 over e 3x minus 1 dx. So in order to do integration, I need to bring up the denominator. Then I will have e to the power of 3x minus 1. It takes negative power now, minus 3x plus 1. So now I can integrate by using formula number 5. So the first step is differentiate the power. Differentiate minus 3x plus 1, it will get minus 3. So we divide by minus 3, and then we write back the exponent, then plus c. Okay, now we move on. Formula number 6. Integrate e to the power of ax dx equal to 1 over a e ax plus c. So what happened here is same idea. You differentiate the power, differentiate ax, you get a, so you divide by a, then you write back the exponent. So number 6. Okay, let's say I have e to the power of 1 over 2x. So you differentiate the power, you differentiate half x, you get half. So you divide by half. 1 divided by half, write back the exponent, then simplify. So this is what we get. Okay, now we look at formula number 7. This is the general formula for exponent. Okay, so integrate f prime of x e fx. So what happened is you have to make sure the f prime of x, the derivative of the power, is staying in front of the exponent. If that happens, then it becomes e to the power of fx plus c. Okay, now let's say one example for this formula. Okay, so I'm going to use question from page 11. Question number 16. Okay, so this is based on formula 7. So based on the questions, we have integration of sine 3x e cos 3x dx. So first of all, when you want to do integration for this, we have to check the power. I let the power as fx. Then I need to do differentiation to check what I get. So I know that to differentiate cos 3x, I have to differentiate 3x first. Differentiate 3x, I get 3. Differentiate cos, I get negative sign. Okay, so this is my f prime of x. So I realized that the sine 3x that stay in front of the exponent, it is not f prime of x yet. So we need minus 3. And because of that, I can multiply with minus 3 over here. Then I divide by minus 3 outside to balance back the value. Okay, so after doing so, now the front part is f prime of x. The power is fx. So based on the formula, when we have these, now it becomes e to the power of fx plus c. So the negative 1 over 3 that stay in front of the integral, it remains, and then e to the power of cos 3x plus c. Okay, now let's continue. Formula number 8. Formula number 8, as you can see, integrate 1 over x, you will get ln x plus c. Okay, so this is the most basic situation. So condition x is greater than 0. Formula number 9, integrate 1 over x dx, you will get ln modulus x plus c. So we put a modulus x if the question never say your x is greater than 0, then you put modulus x. Okay, so number 10, a general form, integrate f prime of x over fx, it is equal to ln modulus fx plus c. Okay, now let's see one example based on formula number 10. Okay, so I'm going to use page 11, question number, let's say number 21. Okay, so we have integrate 1 over 1 plus e minus x dx. So for these questions, it is a fractions, so maybe you feel like want to use previous formula like formula 4, 5, 6. Okay, because of the 1 plus exponent, so we can't use those formula 4, 5, 6 are not applicable, so we had to use formula 10. So how to use formula 10? It seems like it doesn't work well also, because you may feel like if the bottom is fx, I differentiate the fx, I will get negative e negative x on that's supposed to stay on top, but I don't have that. Okay, so which is true, we don't have that, so we need to use a certain technique. We know that differentiate exponent will get back exponent. Okay, so because of that, we need to purposely multiply something on the numerator and as well as the denominator. So I multiply e to the power of x up and down. So what happened then is, when you do so, then you have ex on top, ex plus 1 at the bottom. And because of that, now let's check. The denominator is going to be the fx. You differentiate it, you will get ex, so which is the numerator. So it seems like it fulfilled that particular form, f prime of x over fx. And because of that, we can change it to ln. Okay, now should we put modulus or not? For your information, we can avoid modulus if you are confirmed that the denominator is always positive. So I know that exponent x plus 1 is always positive, I can avoid the modulus. So if you are having any expression that can be positive or negative, then you must put modulus. Okay, so plus c. So that is how we use formula number 10. Now we look at formula number 11. Formula number 11, integrate f prime x, fx to the power of n. So it's equal to 1 over n plus 1, fx to the power of n plus 1 plus c. Okay, so that means what happened is we plus 1 to the power, then we divide by the new power. Okay, so we can use this formula with condition f prime of x must stay in front. Okay, so let's say one example. Okay, so let us use example, let's say questions on page 11. Number 27. So we have integrations of x square roots of 1 minus x square dx. So in order to use that formula in number 11. Okay, now what to do is we need to let fx equal to 1 minus x squared, and we differentiate, we get negative 2x. Okay, we get negative 2x. So what we get over there is just x. What we have in front of the square root is just x. We need negative 2, so I multiply with negative 2 and I divide by negative 2. So by doing so, I have the f prime of x in front, and then let me write again. The negative 2x is the f prime of x. The square root, I change it to power half. Okay, now what I have here is I have f prime of x, fx to the power of n. So based on the formula, what happened then is it will become fx to the power of n plus 1 divided by n plus 1. So we have 1 minus x squared, the power half, you plus 1, it becomes 3 over 2, and then divide by 3 over 2 plus c. Okay, by simplifying this, the 3 over 2 at the bottom, so it becomes 2 over 3. 2 over 3 multiplied with 1 over 2, you get negative 1 over 3. 1 minus x squared to the power of 3 over 2 plus c. So this is the answer for question 27. Okay, now let's move on. We look at the formula again. Formula number 12. Okay, so let's take a look. This one. Integrate f prime of x over square roots of fx dx equal to 2 square roots of fx plus c. So what formula is this? This formula is actually based on number 11. So for example, let's see. Formula number 12. Integrate f prime of x over square roots of fx dx. This is actually f prime of x, fx to the power of negative half. Then when you integrate based on formula number 11, so what happened is to the power, it become power half, then we divide by half plus c, and then after that you will get 2 square roots of fx plus c. So it's the similar concept. It is based on formula number 11. Okay, now let's see example. Okay, so I use question on page 11. This is number 12, based on formula 12. Okay, question on page 11, number 29. So we have integration of x 4 minus x squared dx. Okay, so now we have to check first. Our fx is 4 minus x squared. This we get minus 2x. So we need negative 2. So we divide by negative 2. And based on the formula, it will become 2 square roots of 4 minus x squared plus c. So simplify it, negative 4 minus x squared square root plus c. Okay, so that is the answer if we use formula number 12. Now let us continue. We look at formula number 13. So you can see here, formula number 13, integrate ax dx equal to 1 over ln a ax plus c. Okay, so let's understand this formula by looking at differentiation. Okay, so in differentiation, we have y equal to ax. So to do differentiation on this, we need to ln both sides. And we can bring the power x in front. And we can start doing differentiation based on implicit differentiation. We get this. Differentiate constant x, you get the constant. So dy dx is y ln a, and y is ax ln a. So this is our dy dx. Now how is this related to the formula in number 13? Okay, so we know that when we integrate dy dx, then we will get y. Okay, so we'll get y. Now I divide by ln a on both sides of the equation. Then I will get ax dx equal to divide by ln a. Okay, c divide by ln a, let's say I get another constant. I let it equal to k. Okay, so that is how we get the formula. Okay, now let's see example. Okay, example on page 11. Page 11, number 33. So where we need to integrate 1 over 5 to the power of x dx. Okay, so 5 to the power of negative x, or simplify it to 1 over 5 x dx. So where 5 take power negative 1, so that's why it become 1 over 5. Okay, now I can see my a clearly. So by using the formula in number 13, so what happened is it will become 1 over ln a to the power of x plus c. So to simplify this, I can change the 1 over 5 to 5 to the power of negative 1. Okay, then I shift the negative 1 in front. Okay, so I will get this after integration. Okay, now let's see the answer first. Okay, so the answer do a little bit more. Okay, so this power x, right? So you can give it to numerator as well as denominator. Giving power x to numerator will end up with 1 because 1 to the power of x is still 1. Giving power x to the denominator will end up with 5 to the power of x. So this is the answer given at the back. Okay, so that is all the formula from number 1 to number 13. Now let us continue with number 3. Number 3 is about integrate rational function by means of decomposition into partial fraction. Okay, so that means we have to do partial fraction as our first steps. Okay, do partial fraction. After doing partial fractions, then we can use formula in the general integration on top, especially these two. Integrate 1 over x become ln modulus x plus c, or integrate f prime of x over fx dx become ln modulus fx plus c. Okay, now let's see one example which involve partial fractions. So for example, let's say I use question on 11, number 34. Okay, so we have integrate x minus 13 x squared minus x minus 16 dx. Okay, sorry, not 16, it's just 6. Okay, now to do this, first we have to do partial fraction. I take out the fractions, factorize the denominator, then let it equal to a over x minus 3, b over x plus 2. Then I get this. Okay, then I let x equal to negative 2. I get negative 15 equal to negative 5b. So I get b equal to 3. So I let x equal to 3. So I get negative 10 equal to 5a. So a equal to negative 2. Okay, now I have my partial fractions. Okay, I put it in the integral straight away. So I have negative 2 over x minus 3 plus 3 over x plus 2 dx. So I'm going to use formula over here. This formula, f prime of x over fx equal to ln fx. Okay, I want to use this formula. Okay, so I factorize negative 2 because I know that the differentiation of x minus 3 will end up with 1. So I factorize 3 because I know that the differentiation of x plus 2 is also 1. Okay, now I have f prime of x over fx. So it becomes ln modulus x minus 3 plus 3 ln modulus x plus 2 plus c. So this is the final answer for questions 34. Okay, so that is how we use partial fractions followed by integration. Okay, now let's move on to the next page. Integration of trigonometric identities. Okay, so number 1, we have integration of cos x, we get sin x plus c. Okay, so integrate cos becomes sin. Number 2, integration of cos ax plus b become 1 over a. So where is the 1 over a coming from? It's coming from the differentiation of ax plus b. Differentiate ax plus b, you get a, so you divide by a. And then cos, you integrate, it becomes sine. Take back the same angle, ax plus b. Then plus c. Okay, next formula. Formula number 3, integrate sine x. Integrate sine x, it becomes negative cos x plus c. Number 4, integrate sine ax plus b. So it's equal to 1 over a first. So 1 over a again, you differentiate the angle, differentiate ax plus b, you get a. So you divide by a. Then you integrate the sine, become negative cos, take back the same angle, ax plus b. So don't forget to put plus c at the end. So I have to put plus c here. Okay, now let's see formula. Okay, formula. So based on number 2, I can give one example. Based on formula number 2, I can give example from page 13. Number 1. So they want us to integrate cos 2 pi over n x dx. So what we need to do is we differentiate 2 pi over n x. So we will get 2 pi over n. So we divide by 2 pi over n. Integrate cos becomes sine. Take back the same angle plus c. Simplify and get this. Okay, so that is formula number 2. Okay, for formula number 4, I can also give one example. Let's say formula number 4. Let's see page 13, number 4. So we have integration of 3 sine 5 minus 2x. So you differentiate the power, you get -2, you divide by -2. Okay, differentiate the angle, differentiate the angle, differentiate 5 minus 2x, you get -2, so you divide by -2. Okay, so the 3 remain there. Differentiate sine, you will get negative cos, so negative cos 5 minus 2x plus c. Okay, now we simplify this, we end up with 3/2 cos 5 minus 2x plus c. So that is how we handle question 4. Okay, now let's move on. We look at the formula again. Integrate secant square x become tangent x plus c. Integrate secant square px, differentiate the power, differentiate the angle px, then you get 1/, then you get p, then you divide by p. So that's why there is a 1/p here. Then secant square you integrate become tangent, take back the same angle, px plus c. Okay, now let's see one example. Okay, so for formula number 6, we can refer to page 13, questions 5. Okay, so integrate secant square 4/5x dx. Okay, first we differentiate the power, we get 4/5, so we divide by 4/5. Secant square you integrate, you get tangent. Simplify it, become 5/4 tangent 4/5x plus c. Okay, so that is number 6. Now let's move on. Number 7, integrate secant x tangent x equal to secant x plus c. Number 8, integrate secant px tangent px equal to 1/p. 1/p come from the differentiation of the angle. Differentiate angle px, you get p, then you divide by p. And then we know secant tangent, you integrate, it becomes secant. So that's why secant, take back the same angle, px plus c. Okay, so let's move on. Okay, number 9. Integrate cosecant square x dx equal to negative cotangent x plus c. Integrate cosecant square px dx equal to negative 1/p. So again, the p comes from the differentiation of the angle px. Then you get p, you divide by p. Then we know integrate cosecant square, we end up with negative cotangent, and then take back the same angle px plus c. Okay, now number 11, integrate cosecant x cotangent x dx equal to negative cosecant x plus c. Okay, so number 12, integrate cosecant px cotangent px equal to negative 1/p. So the p comes from the differentiation of the angle px. You differentiate px, you get p, so you divide by p. And then integration of cosecant cotangent, we end up with negative cosecant. Take back the same angle px plus c. Okay, so we have a not standard formula, which is formula number 13. Integrate tangent x. Integrate tangent x become negative ln modulus cos x plus c. Okay, so we need to understand how is this formula works. So number 13, integrate tangent x dx, you change it to sine x over cos x. So based on the formula that we learned just now, integrate f prime of x over fx equal to ln modulus fx So we need to know that our denominator is now the fx. We differentiate it, we get negative sine x. So we need a negative. So I put a negative here, I put another negative outside to balance back. Then negative ln modulus cos x plus c. So that is why we have that formula 13. Formula 14 is just similar. Integrate cot x dx. I change cot to cos over sine. Then I use the formula of f prime of x over fx. I will get ln sine x plus c. Formula 15, integrate secant x dx. Okay, so this is a special case. We need to purposely multiply with secant x plus tangent x, secant x plus tangent x. By multiplying with this, what happened then is we will get f prime of x over fx. So as you can see here, I multiply secant x to the numerator, and the denominator I purposely exchange the position, tangent x plus secant x. So we will see f prime of x over fx now. As you know, differentiation of tangent x, you will get secant square x. Differentiation of secant x, you will get secant x tangent x. So this is where we have f prime of x over fx, and by using the formula, we will get ln modulus tangent x plus secant x modulus plus c. Okay, so that is how we get formula number 15. Okay, now let's see some examples on the applications of everything here. Okay, now let's say I use page 13. Number 7. Okay, number 8. Okay, number 8 as my example. Okay, we integrate sine 2x sine x dx. Okay, so in order to integrate this, what we can do is we use double angle formula. Then we simplify it. We get this. So how we integrate after that is we use this formula. Integrate f prime of x, fx to the power of n equal to 1 over n plus 1, fx to the power of n plus 1 dx. So we use this formula to handle these questions. So first, we need to know that the one with power is sine x. So we call it fx, and then I differentiate it. I know that differentiation of sine x is cos x. Okay, so I can use the formula. Then I will get sine to the power of 3x divided by 3. The 2 is still there. Divide by 3. The f prime of x disappear. Then plus c. Okay, so that is how we get the answer based on that formula. Okay, now let's move on. Number 5. Integrate sine to the power of nx. Integrate cos to the power of nx. N is odd number in which n is more than or equal to 3. N is a positive integers. So that means we have integration of sine power 3 or sine power 5, okay, odd power. So how we integrate, you look at the steps here. So for this odd power, you express n equal to 2n plus 1. Okay, so let's say I give one example in the meantime. Okay, so let's say I look at page 14. Page 14, question 1 on top, extra exercise 3. So I have integration of sine power 3x dx. So based on step 1, I have to change this to 2m plus 1. That is 2, 1 plus 1. Okay. So the reason that we do so is so that we can separate. We can separate it to sine square x and sine x. So it seems like the 2m plus 1 is very useless there. So let's see one more example at the same time. Okay, so I do page 14, number 3 over here at the same time. We have integration of sine power 5. Okay, so based on the first step, I have to change it to 2m plus 1, which is 2 plus 1. Okay, so we need to keep the power 2, then another power 2 remain outside, then sine x. Okay, so that is the basic idea. We need to keep sine x away from the rest. For the sine square x, we use step 2, identity. Change sine square to 1 minus cos square x. Expand it. Sine x cos square x dx. Okay. Now integrate sine x, negative cos x. Integrate sine x cos square x, you have to use the formula f prime x. Okay, I write down the formula here. F prime x, fx to the power of n. So it becomes 1 over n plus 1, fx to the power of n plus 1. So plus c. We have to use this formula. Okay, now I know that fx is my cos x, f prime of x is negative sine x. Okay, so my f prime of x is all this, include the negative. Okay, now the negative will be taken as f prime of x, so end up with positive. So I need to plus 1 to the power, so I will get 3. So I divide by 3, cos cube x dx. Okay, sorry, no more dx. After integration, no more dx, plus c. So that is the answer. Okay, so if I have power 5, so how we handle it? Similarly, for the sine square, we use identity 1 minus cos square. Then we expand it, 1 minus 2 cos square x plus cos power 4x sine x dx. Expand it, sine x minus 2 sine x cos square x plus sine x cos 4x dx. Okay, now integrate, sine become negative cos. Integrate the second term. I use the same formula just now, the one in blue color on the screen. Okay, so it is going to be positive 2 over 3 cos 3x. Now for the third term, I use that formula again, the formula in blue. So I will get negative 1 over 5 cos 5x plus c. Okay, so that is how we handle the integrations involving odd power of cos and sine. Okay, now let's move on. Now let us look at number 6, integration of sine to the power of nx dx, integration of cos to the power of nx dx. N is an even number. Okay, so now the power is even number. What we need to do is step 1, express n equal to 2m. Okay, so where m is a positive integer. Okay, so for example, if you have integration of sine to the power of nx, you change it to integration of sine square x to the power of m. Okay, so that is the reason why we change it to 2m. So the power 2 you keep inside the bracket, and then the power m you put outside of the bracket. If you have cos to the power of nx, you keep the power 2 inside the bracket, cos 2x, and then the power m you put it outside of the bracket. So let's say one example. Okay, so I will take example on page 20. Questions 13. Okay, so we have integration of sine to the power of 4x. So we change it to sine square x square again. Okay, so that is step 1. Now step 2, we have to use different identities. So remember that if it is odd power, we use sine square x equal to 1 minus cos square x. We use cos square x equal to 1 minus sine square x. This is for odd power. Now for even power, the identity that we use is coming from the double angle. So if you are not sure on which formula am I talking about, so I write it here. It is cos 2x equal to 2 cos square x minus 1 equal to 1 minus 2 sine square x. So it is from these two double angle formula, and we rearrange them and we get these two. Okay, so we use different identity for even power. Now let's continue. For cos square, you change it to half 1 plus cos 2x. So why we need to change it? We change it so that we can integrate by using a particular formula. So if you have sine square, you change it to half 1 minus cos 2x. Okay, so let's see the example here. Okay, now I have sine square in the bracket, so I change it to half 1 minus cos 2x. So the whole thing, power 2. Expand it, 1 over 4, 1 minus 2 cos 2x plus cos square 2x dx. Expand again, so now when you look at the third term, you will realize that the third term is again an even power. So we have to use the formula again. But you have to know if it is cos square 2x, so based on the identity, if you have cos square x, it becomes 1 over 2, 1 plus cos 2x. But the thing is, if you have cos square 2x, it becomes 1 over 2, 1 plus cos 4x. Okay, so we apply the second formula into the last term. So now we will get integration 1 over 4 minus 1 over 2 cos 2x plus 1 over 4 1 over 2 1 plus cos 4x dx. Integrations, I'm going to have 1 over 4 minus 1 over 2 cos 2x plus 1 over a plus 1 over a cos 4x dx. Okay, so we add up 1 over 4 plus 1 over 8, we will get 3 over 8. 3 over 8 minus 1 over 2 cos 2x plus 1 over 8 cos 4x dx, and we integrate this to 3 over 8x. So when you integrate cos 2x, first you differentiate the angle, you get 2, then you divide by 2. So because of that, you have 1 over 4. Integrate of cos becomes sine. So when you integrate cos 4x, first you look at the angle, you differentiate the 4x, you get 4, so you divide by 4, and hence you get 1 over 32 sine 4x plus c. So that is the final answer. Okay, so question 13, let's check first. Okay, so this answer is correct. Okay, so that is how we handle even power. Okay, now let's move on. Okay, so this is what we have gone through just now. If you have sine to the power of nx, you change it to sine square x to the power of m, then you apply the identity, and then you can integrate afterwards. So likewise, for cos to the power of nx, you make cos square x in the bracket and the remaining power outside, and then you use the identity, then you can just integrate. Okay, so we have done for even power. Okay, now let's see number 7. Number 7 is a situation where we have integration of sine to the power of mx, cos to the power of nx. There are 3 kinds of situation, both m and n are odd. Choose the smaller power and apply the identity. Okay, so apply the identity. Which identity am I talking about? So if they are odd, remember, for odd power, we apply this identity. Okay, so if you have one odd power and one even power, choose the odd power and apply identity. Apply the odd power identity. If you have both m and n are even, choose the smaller power. Actually, if both of them has even power, so you have to choose both and apply the even power identity, which are these two identities. Okay, so choose both of the even power expression and apply the identity on both. Okay, let's see example. Okay, so for example again, let us choose questions from page 20. Okay, so I'm going to choose a question involving odd power for both. Let's try question 29. So we have integration of sine cube 3x cos 5 3x. So according to the guidelines written there, we have to choose the smaller odd power, which is power 3, and then we apply the odd power identity. So what we need to do is we change it to sine 2 3x sine 3x. So the odd power, which is higher, we remain it. And now for the sine square, we change it, we use identity, change it to 1 minus cos square 3x. Then sine 3x cos 5 3x dx. Then we expand, we will get sine 3x cos 5 3x then we will get sine 3x cos 7 3x dx. Okay, then we can integrate. So what formula am I considering? I'm considering integration of f prime x, fx to the power of n, end up with 1 over n plus 1, fx to the power of n plus 1 plus c. Okay, so what we get here, I know integration of cos is differentiation. Okay, so differentiation of cos 3x is negative 3 sine 3x. Okay, so that is what we know. So because of that, we need negative 3 in front of the sine so that it becomes f prime of x. Okay, so because of that, I have to multiply with negative 3 purposely. But multiplying with negative 3 is changing the value of the question, so I have to balance back. I divide by negative 3. Okay, so you get something like this. Okay, so now I have f prime of x, fx to the power of n. So I use the formula now. For the first term, I will get 1 over 6 cos 6 3x. For the second term, I will get 1 over 8 cos 8 3x plus c. Okay, so simplify this. Negative 1 over 18 cos 6 3x. Positive 1 over 24 cos 8 3x plus c. Okay, so this is what we get for question 29. Okay, so remember, if you have both trigon with odd power, take the smaller odd power and apply the odd power identity as in here. Change the sine square to 1 minus cos square. So now let's see one odd power and one even power. Basically, it's just similar. Okay, so you choose the odd power and then you apply the odd power identity. Okay, so let's see one example. Page 20, question 23. So we have integration of sine cube 4x cos square 4x dx. Okay, so for the sine cube, this is the odd power. We change it to sine square 4x and sine 4x. Then we apply the odd power identity, which is 1 minus cos square 4x. So we write back the rest. Expand it. Use back the same formula like just now to integrate it. So I know I need to have a negative 4 for both, so I divide by negative 4. And then I can put negative 4 here, and the back also, negative 4. So I have the f prime of x in front of the fx to the power of n. Now by using the formula, so I will get 1 over 3 cos 3 4x minus 1 over 5 cos 5 4x plus c negative 1 over 12 cos cube 4x plus 1 over 20 cos 5 4x plus c. Okay, so that is what we get at the end for question 23. Okay, now let's see one example that involves even power for both. Okay, so I'm going to use page 20 again. Number 20. So I have the integration of sine square half x cos square half x dx. Okay, so change both of the even power trigo expressions by using the even power identity. So the even power identity, of course, it is this one. Okay, so you look at the arrow here. So this is the even power identity. Cos square to half 1 plus cos 2x. Sine square x to half 1 minus cos 2x. So use this identity instead. Okay, so if we are using that, so it will become 1 minus cos x. One over 2, 1 plus cos x. Okay. So then we have 1 over 4, 1 minus cos square x. Okay, so after we expand that, so now we have even power, so we have to use the even power identity one more time. So we will get 1 over 4 minus 1 over 4, 1 over 2, 1 plus cos 2x. So 1 over 4, 1 over 8 minus 1 over 8 cos 2x dx. So minus this, I will get 1 over 8 minus 1 over 8 cos 2x. So I can integrate now. 1 over 8x minus, okay, differentiate the angle and get 2, then divide by 2, so 1 over 16. Integrate cos becomes sine, then plus c. Okay, so this is the answer. Okay, so question 20. Yeah, okay, so correct. This is the final answer.